In this video, we're going to be discussing continuity of the graph from the left or from the right. And this is useful when considering the continuity of the endpoints of a graph. Okay, so in the last video when we were talking about functions, we were looking at a lot of the functions that we looked at. Whoops, sorry about that. Even the piecewise defined functions, things of this nature, they proceed off to the left and the right infinitely in both directions. So they don't have endpoints. And similarly, if we're thinking about something like just a quadratic function, it also doesn't have endpoints. But sometimes when we're looking at graphs that have defined endpoints, we might need to think about continuity there. So let's look at something like a half circle graph, something like this, for example. Well, this graph does not continue off forever to the left and the right. It is only defined between these two x values, right? X1 and X2. So if we are taking a look at this function and we want to consider, is it continuous? Well, we certainly know it would be continuous in between those 2 points because the entirety of the graph, again, can be drawn without lifting up my pencil. It's a nice smooth curve. There's no holes, breaks, jumps, asymptotes, nothing like that. We might be concerned about the endpoints of the graph. However, we can actually apply our rules for continuity to the endpoints and just replace the requirements for continuity with a one-sided limit instead of a two-sided limit. So for example, when considering this endpoint on the left, we can ask ourselves, if we want to know if it's continuous there, does the limit exist? But we're only going to be considering the limit as we come from the right. Okay, we're not going to be looking at it from the left because there's no function over here. It's not defined at that point. The function actually starts at the value of x1. So does a limit exist there? Is the limit equal to the value of the function at that point? All of those standard continuity requirements are satisfied as long as we consider a one-sided limit for that endpoint. And then we can consider the same types of things when looking at x2, but we will only be considering the limit as we come from the left-hand side because there's no graph over here, right? The function isn't existing anymore. And so, again, similarly, does the limit exist? Is the limit equal to the value of the function at that point? Yes, it does. Okay, so functions like this that are not defined across the entire range of x values, but have a starting and a stopping point, we can still consider them to be continuous if, again, those endpoints meet the one-sided limit criteria instead of the two-sided limit criteria that we talked about in the previous video.